Hello, today I'll show you how I bought a broken refrigerator at a bargain and repaired it with almost no extra cost. Also, we're going to learn about the engineering behind it and how we can make them more efficient. There are three main refrigerator types. The classic compressor refrigerator is the common household model. The Peltier electric refrigerator, which is the worst of all, and this absorption refrigerator. I chose this refrigerator, obviously, because of the price. It seemed super cheap to me, since I only paid about $20 for it. The seller said that the refrigerator didn't work, but one of the reasons I decided to buy it is that it's an absorption refrigerator. A refrigerator that works with water and ammonia and without any moving parts, just with a heat source. This lets us use it not only with electricity, using a heating element, but also with gas or any flame. I've always found this refrigerator interesting, but how does it work? Let's look at the back of the refrigerator. The refrigerator is filled inside with a mixture of ammonia and water, which is heated by the source we mentioned, and as it evaporates, it rises. Only the ammonia manages to rise all the way to the top since the water is condensed again and falls back down. The ammonia loses temperature as it falls through the condenser and returns to its liquid state. A hydrogen conduit aids this process. Once ammonia liquefies, it enters the refrigerator's evaporator. By absorbing the heat inside, what it does is turn back into gas. This causes it to absorb the heat inside. Then it returns to a pipe where the ammonia mixes with the water again and the process repeats. These refrigerators can last for many years, and the main failure is very simple to repair. Over the years, ammonia crystals start to form inside the pipes, eventually clogging them, and repairing them is actually really easy. First, we're going to turn the refrigerator upside down, and now we're going to hit it with something not too hard. I used the handle of one screwdriver. Plastic? These refrigerators are sturdy because they are made of steel. Otherwise, the copper or aluminum would be corroded by the ammonia itself and would be destroyed. When we hit it, we dissolve the crystals, break them up, and help the ammonia and water circulate to unclog the system. We hit it every hour for an entire day, then we turn it over and leave it for another day to let it settle. And that's it. With this, it should work again. The other problem with this fridge was that the heating element was broken, so I replaced it with the same kind. This heating element is electronic and 220 volts, but I tested it using 12-volt resistors from a 3D printer. And you can even use it with a candle or any flame. This is what makes it perfect for example, a motorhome. Since they can refrigerate food using the same gas they use for cooking without using electricity. That's something I think is a big plus, no doubt. Since in a camper, electricity isn't something you have in abundance. Because of the years and condensation, it had a lot of rust, so I literally took it all apart until I was left with just the cooling system. As mentioned, it was steel and rusted everywhere. I removed as much rust as I could with wire brushes. And once all the rust was removed, I painted the whole system again with anti-rust paint so it wouldn't rust again or spread any rust that might have been left. Now it was time to reassemble everything. For this, I designed my own cabinet because the one I had was many years out of date. Who knows when this thing was made? I simply made a box the same size as the refrigerator out of 18mm white melamine. And at the top, I left a small drawer so I could put things like cookies or food of that kind in there. As you can see, the refrigerator frame was already pretty much assembled, so I just glued it inside the wooden pieces I had made. It's mostly just to give it an aesthetic touch. It's not really useful for anything. Now, the original system had the evaporator embedded in some foam that I had to remove. So I tried to recreate the same shape using expanded polystyrene. I cut several pieces and glued them together with polystyrene foam. Once I checked that the shape was what I needed, I finally put the system inside the refrigerator. On the inside, I sealed the thermal leaks with more polystyrene foam and white silicone. I glued the lid on to make it look nicer. The evaporator included a small aluminum tray to help distribute the cold. It's usually attached with any glue, but I used a thermal adhesive. This will simplify the process. On that tray, we have to screw in the temperature sensor coil. This is the one that will turn off the refrigerator once the desired temperature is reached. That way, the temperature knob would no longer work. I painted the lid white, the only part kept from the original refrigerator, and added a snap lock to ensure it closes properly. Now the refrigerator works perfectly. At the bottom, I put some little feet on it that I printed with Grelon's black PLA filament. Tres, which is the brand I'm currently using because it has a lot of variety and the quality is excellent. I put it in my desk corner. By the way, if you want to see how I set up my entire computer, I'll leave the video here in the corner. But it lacked something. I wanted to make it more efficient. To start, the fridge had a magnetic latch that, although it worked, the door didn't close tightly, so the cold air would escape. I tried several ways, but without a doubt, the best was to put this hook-type pressure latch, which holds the door tightly once it's closed. Also, if the fridge were in a camper, it would be ideal to keep the door from opening. With that solved, there was another problem. The heat from the resistor would rise and warm up the condenser, so the ammonia wouldn't cool properly, and this kept the fridge from cooling at its full potential. What I did was open some vents at the top. There are just a few holes. Maybe a grill would make them look better. Since they weren't visible, I left them. The whole saw broke while I was making them, so I only made 2. Oh well. And to make it cool even more, I made a bracket by bending some aluminum rods and screwed it to the chassis. There I placed a 220-volt fan which blows air directly onto the condenser, keeping it always cool. I connected the fan in parallel to the heating element, so when the heating element turns off, the fan will also turn off. Using this simple trick, our interior temperature dropped from about 10 degrees to minus 10 degrees. And don't worry, to keep the water from freezing, we just adjust the temperature knob and that's it. By the way, that 6-liter jug with hoses is part of another project that I'll upload soon. Let me point out that 75% of my audience isn't subscribed. So if we get 10,000 new subscribers, I'll upload the new video right away since I already have it finished. Anyway, sure. It's a very interesting refrigerator, which has its pros like the fact that it doesn't make any noise and can be used with any heat source. And its cons? Like the fact that it cools down very slowly and uses much more electricity than a compressor refrigerator. But that's how it turned out. As you can see, it cools perfectly. The water is basically ice cold, almost freezing, and I think it's perfect to have it here in the office. Thanks to Ivan M, CE, Joaquin, and Paz for subscribing on Patreon. If you've read this far, consider joining Patreon too. This lets you watch videos before they're on YouTube and access exclusive content. Thanks for watching. If you enjoyed, please subscribe and like. See you next time. Bye.